Hi guys. As promised during class today, we're going to do some examples with actual numbers in them of everything that we talked about in class. So in class was kind of the prequel of what you needed to know before doing today's notes. I did post an optional worksheet that you could print out to follow along today. It looks like this. It's a nice guided little flowchart, and the PowerPoint is going to look exactly like the flowchart. So it's going to be really helpful if you are able to print this out. And also, your homework looks like this too. Okay, so this is actually tonight's homework that I printed out. And it's just got 2 questions and one that goes along with each of our videos. And then it has the nice flowchart to remind you of everything that we're looking for. Now, I added some extra information on my flowchart on my PowerPoint. So you want to pause the video right now and you can write down this extra information, like underneath axis of symmetry, it gives you the formula for the axis of symmetry. So if you want to write that right here, right, you can. I give you some extra space and you can write down how to find the vertex and all that. So feel free to pause the video and write down any of this top information that you need to. And then when you're ready, you're going to write down the equation right here for our first example. So hopefully you were able to write down everything that you needed to, and you're ready to start our example. Don't forget to write down the equation. So the flowchart is actually going to lead us through the steps that we should take, with the exception of, I'm going to flip-flop the last 2 boxes, but we wanted to put the graph all the way at the end. But the flowchart tells us that the first thing that we should do is we should find our axis of symmetry. And it gave you a formula, and we learned this in class today, x equals negative b over 2a. So in this problem, my b is 6, and my a is an invisible 1 in front of the x squared. So when I plug that in, I get x equals negative 6 over 2 times 1. And then we do a teeny tiny bit of math, and we find out that our axis of symmetry is x equals negative 3. And I'm going to put a box around everything that is considered to be an answer today. So this is an answer to a question. The question is, what is the axis of symmetry? And the answer is x equals negative 3. You do have to have the x equals in there. You cannot just type the number negative 3. My next step in my flowchart is finding the vertex. To find the vertex, I'm going to take the number that I found from the axis of symmetry, and I'm going to plug it into the original problem and solve for y. So here I've plugged in negative 3 for both of these x's. Notice that I surrounded it with parentheses. That's very important, especially if it's negative. And then you can either type this whole thing into your calculator exactly how it looks, or you can do it in your head. Right? These numbers are not too big. You should be able to do this without a calculator. Don't forget, a negative number squared turns into a positive number. And I get my y coordinate for my vertex is negative 1. Now the vertex is an ordered pair, so we're not going to leave it y equals negative 1. We're going to write it in parentheses with our x number, negative 3, and then our y number, negative 1. This is also an answer to a question, right? So the question is, what's the vertex? And the answer is negative 3, comma, negative 1. At this point in time, you could actually start graphing these things. So I don't know if you noticed over here on my graph, I've already graphed my axis of symmetry. X equals negative 3, so I went left 3, and drew a nice dotted line through the negative 3. If you don't want to draw a dotted line, you could use a highlighter, but you can't draw a solid line with your pencil. So either use a highlighter or draw a dotted line. My vertex should be somewhere on that dotted line. So negative 3, negative 1 is right here. So as soon as you find out those 2 things, you can actually start graphing if you want to. Next, I have actually 4 questions. Does it open up or down? Does it have a min or max? What is the domain? And what is the range? So this is a total of 4 questions. Now for these problems, you don't have to do any work. It's just going to be really quick answers. We're going to really focus on the letter A to figure out the answer to these questions. And the letter A in this problem is a positive 1. Since A is positive, this parabola will open up like a regular U shape. And anytime a parabola opens up, it has a lowest point or a minimum. Since A is positive 1, this opens up and has a minimum. We learned in class today that the domain is always all real numbers. You can just use that fancy R if you want to. That's an instant answer. And then the range When a is positive, the range is y is greater than or equal to, and then you want to use your y number from your vertex, which in this problem was -1. Again, these are 4 answers to 4 questions. My parabola opens up, it has a minimum, my domain is all real numbers, and my range is y is greater than or equal to -1. Next, I'm going to answer what the y-intercept is. And the y-intercept we learned in class today is just whatever the c is from the equation. That's the last number. So in this problem, my y-intercept is 8. And we're going to write it as an ordered pair since it's a dot, 0, 8. Look at that, guys. We answered like 4, 5, 6, 7 questions so quickly, okay? Now I'm going to skip the x-intercepts because best case scenario, I'm going to be able to stare at the graph and find the x-intercepts that way. And I won't have to do any calculations to find the x-intercepts. So I'm going to skip the x-intercepts and I'm going to go to graphing. Now for graphing, I've already got my starting point, my vertex. It's down here. And now I'm going to use my special ordered pairs, which are 1, 1a, 2, 4a, and 3, 9a. And those came from our parent function that we did at the very beginning of our live class today. And the a in these ordered pairs refers to the a in the equation. And in this problem, my a is just that +1. And you want to multiply your y coordinate by the a, and that will change it from like normal to skinny to wide. Since it's just 1, nothing's going to change. So 1 times 1 is just 1. Now again, these are special ordered pairs. So you want to put your pencil on the vertex. And from the vertex, you're going to go 1, 1. And then you're going to reflect. So you're going to go left 1 and up 1. Okay. My next special ordered pair, 2, 4. 4 times 1 is still 4. So just remember, always put your pencil back on the vertex. So all the way down here. And then go right 2 and up 1, 2, 3, 4. You want to reflect on this side as well. Okay. And then I think your guys' graph's a little bit bigger than mine, so you should be able to do the next special ordered pair, which is 3, 9. So you want to do as many ordered pairs as you can fit on the graph that you are given. So again, going back down to my vertex, all the way down here, I'm going to go right 3, which puts me on my y-axis, and I'm going to go up 9, and it would put me somewhere up here. Now, I can't fit that on mine, but you should be able to. So go right 3 and up 9. And then since we're on the y-axis, also make sure that wherever you put your dot, it was actually on the +8, because that's what we predicted that the y-intercept would be. So you can use your y-intercept as a prediction of where you think that the graph should be, and then when you graph it, just check and make sure that you got it right. And then we do want to connect the dots with that nice U shape. Okay? It does need to be a U, it's not a V. There's actually a different equation that will graph a V. Once you've graphed your parabola, you can go back and answer that last question, which is where are the x-intercepts? Now, the x-intercepts are where it crosses the x-axis. And in this example, it crosses it twice. It crosses right here. And the ordered pair for that dot is -4, 0. And then it crosses a second time over here. And the ordered pair for that dot is -2, 0. Since there are 2 separate x-intercepts, you do want to write 2 separate ordered pairs. And that's it. We've answered all of the questions. So this was our first example, and I'm going to make a second video with the second example. In our second example, we'll have different x-intercepts, but everything else will pretty much stay the same.